Alright, hello again. I want to make a video on some of the things that I've been working on recently. I kind of been coming into a couple of speed bumps on some of my projects, so I've been just brainstorming and working on some wireless electricity ideas again. I got inspired by this Slayer exciter that I seen people do this like a few years ago with some CFL bulbs, but I've been always wanting I always wanted to make that circuit, but I never got around to it. So I'm finally doing it. So I'm going to go over that in a second. But um, I just wanted to point out real quick for any projects that you're doing with circuitry or anything like that. I found that there's a ton of resistors on the back of these clocks. See, and they all have their the length of the wire is still pretty long on them, so when you clip them out, you still got a lot of wire to use if you want to stick them in another circuit board. So I just wanted to point that out with the clock real quick before I go. And now I want to go over these battery chargers before I go into this Slayer exciter thing. See, this is just a standard wall battery charger. It can charge 4 AA's or 4 AAA's. It's one of those 15-minute chargers. And what I wanted to point out in this setup here is that this over here is going to be AC. I mean, I could show that to you with this. This over here is AC, and this is going to turn it into a DC over here. So I guess I'll just plug that in and show you what it's going to be. Okay. Okay, there we go. Let's see if I can whip these. Everything's kind of loose here, so bear with me. Okay, here we go. Alright, I tie knots on the side that are the positive side, so it's getting. Oh. Alright, here we go. See if I can get it to stay up. There we go. Alright, what are we getting here? It is putting in 17 volts of DC. But I think it's not a straight DC. What it is, I think it might be a pulsating DC, or one's a DC and one's a pulsating DC. I'm not quite sure. But it usually shows on the back. I don't want to do it now while it's plugged in, but yeah, this is DC, and now we're going into another step up phase, which is DC also. But what's going to happen is we stepped up the voltage with AC, and now that we have high voltage AC, it turned it into a higher voltage DC. And now that it's a higher voltage DC at a 17 volt DC, we're going to change it into a higher amp DC at the price of those more volts. See, I guess this whole process is, I guess you use AC as a step up source, and then when you have it stepped up to your power level desired, then you turn it back into a DC current. And that's what's kind of important about this whole Slayer exciter setup, is that what's going on here is it's kind of like a Tesla coil setup over here for the two coils, L1 and L2. What's happening is that this is a DC battery over here, and what's going on in this circuit is, I think it's doing some kind of like bouncing back and forth, but it makes a pulsating DC current in this thicker coil. See, I got this. This is my setup so far. I ripped apart a speaker from or the plastic speaker part of a phone, and I'm using that as my circuit board. But anyway, you see, I got a ferrite rod here, or AM antenna, and I wrapped a thin wire around it first for the L2, and then I wrapped a thick wire down here at the base for the L1. And the L1 is going to be receiving a, the battery is going to go over here. I'm having trouble trying to find the correct transistor for this circuit. It's the one that only allows the current to go in one direction out this particular arm here in the resistor string. But I'm having trouble trying to find that. If anybody knows where to get those transistors, let me know. Because that's all I need to finish my little experimental setup here. And what these do is they pulsate a DC current in the thick coil, and then that doesn't pulsate another DC current in the thinner coil. What it does is it makes the magnetic field pulsate in and out from the thicker coil. So as the magnetic field pulsates in and out, it makes the electrons flow in one direction in the thin coil, and then as it collapses, it makes them flow in the other direction. So it's making a pulsating current, but it's making this other coil broadcast a alternating current, and it's a radio signal. It's wireless power, but it seems like there's no sparks involved. It seems like it's called the solid state Tesla coil, but yeah, but it's just by getting DC to pulsate. I think that was one of the whole tricks of wireless radio signals, is you get DC to pulsate with a Slayer exciter circuit like this, or get it to kind of, I think it travels like this or something like that, like in a figure eight, like voomp voomp. And as it pulsates like that, it makes an alternating current in the thin coil at a higher voltage. So you're getting a wireless power or pulsating magnetic fields at larger distances with this L2 coil. Now I'm going to post a link with this video as well for an old Army video, and that old Army video will go over radio transmission, and it'll explain how a microphone works the same way as these Slayer exciters do. The microphone is an energized DC. It's a direct current energized electronic apparatus, and when you talk into it, it changes the resistance in the wires that are connected to it. And when it picks up the vibrations, when it gets pushed in by your sound waves from your mouth, it lets the resistance go down, so it makes the electrons flow faster. But when it comes back out, then it makes them go slower. So the speaker starts to vibrate to your voice, letting electrons go fast and slow depending on the vibrations that you're giving the microphone. So the same thing is going to be happening here, but instead of your voice, you're pulsating electromagnetic fields into the coil, and then you take that and you turn it into an alternating current, and then you step it up. The video that I post in this video's description will explain all that. I don't want to explain it in this video, so. Okay, thanks for watching. I just wanted to go over where I'm at. Oh, there was one more thing. I think this is a capacitor, but I'm not quite sure. It says a 6 watt 7.5 kilojoule something. So I think it's one of those capacitors, but I'm not quite sure. And this also, it's not a condenser, because a condenser is like two thin strips of metal, and like a I don't know, like a inductor or some kind of before it. And this has a resistor, and it has two electrodes on the inside of it. So I'm not quite sure what this is or can be used for. But I just wanted to ask if anybody knew what this could be used for. It looks like there's two electrodes inside a vacuum right there for some reason, and it's got a resistor for current. This I'm pretty sure is a capacitor. But this was also interesting. This I found in a old radio. It's a circuit board that has the transistor on it that I'm trying to get for my Slayer exciter setup. But what makes this interesting is this is also another DC to DC setup. See, this plug right here accepts DC from a power adapter, and it turns and it does something with its transistor and setup here to turn it into another DC current at the tip over here. But it got fried or something like that. So I checked it out, and it turns out it needed a new coil. A capacitor on here. The capacitor on here was no good anymore, so I put a new one on there, and it started to work again. See, watch. I'll plug this in. Yeah, and the little light comes on. So it's almost like the same thing that I'm trying to make here, but it's not connected to a battery. It's connected to a power adapter, which is supplying the DC power. I'm sure I could connect this to a battery and it would turn red. It would do the same thing. So I'm going to try to see if I can get DC and turn it into a pulsating DC that'll make electromagnetic waves expand and collapse and create an alternating current and a thinner coil of wire eventually. So, okay, that's where I'm at right now, since I'm at some frustrating parts of my other projects. So, leave a comment if you want. I'm looking for some feedback on this if anybody's out there. Have a good one, and I'll talk to you soon.